So we continue from this, yeah? Okay.
I'm using CentOS 7 as my developer workstation. I'm going to cat out the example1.yaml file and take a look at our playbook. This is the same playbook we looked at in the slide deck. I'll clear the screen, and then I'm going to run the command ansible-playbook, put in the -user parameter for my username developer, and I'm going to run example1.yaml. And this should use Ansible to connect over to the DevNet sandbox and connect into the DevOps computer that I want to configure using my Ansible playbook. Okay, you can see that the play is running. Report hostname and operating system details. Task 1, it's gathering the facts. All right, task 1, get the hostname from the server. There it is, message devbox. And task 2, operating system. And there's the message returned, CentOS. Now for the second play in the playbook, report network details of servers. Okay, the default IPv4 interface and the message returned, there it is, ENS 160. The next task is to retrieve the network routes. Okay, we got a response. Looks like this playbook worked perfectly. You can see the reply back right here. These are the network routes installed.
All right. Okay. So we have seen this video, yeah, for configuration management tools. Okay. Okay, traditional network configuration. Yeah, network devices have traditionally been configured by a network administrator using CLI, yeah, command line. Whenever there is a change or new features, yeah, the necessary configuration command must be manually entered on all of the appropriate devices. This becomes a major issue on a larger network or with a more complex configuration. Okay, like this example, they need to change on router, on this multi-switch and also this hub. Okay, all right. So traditional network configuration, as you know, the SNMP or Simple Network Management Protocol. Okay, let's administrator manage nodes, yeah, on an IP network. With a network management station or NMS, network administrator use SNMP actually to monitor and manage network performance, find and solve network problem, perform queries for statistics. And SNMP is not typically used for configuration due to security concern and difficulty in implementation. You can also use API to automate the deployment and management of network resources. Instead of manually configuring ports, access lists, quality of service, and load balancing policies, you can use tools to automate configuration. Okay, all right. Network automation. We are rapidly moving away from a world where a network administrator manages a few dozen network devices to one where they are deploying and managing a great number of complex network devices, either physical or virtual, with the help of software. Okay, this transformation is quickly spreading to all places in the network. Yeah, there are new and different methods for network administrator to automatically monitor, manage, and also configure the network. These include protocol and technologies, such as REST, Ansible, Puppet, Chef, Python, JSON, XML, and many more. All right. So configuration management tool. Configuration management tool make use of RESTful API requests to automate tasks, can scale across thousands of devices. These are some characteristics of the network that administrators benefit from automating. Software and version control, device attributes such as name, addressing, and also security, protocol configuration, and SCL configuration. Configuration management tool typically include automation and orchestration. Automation is when a tool automatically perform a task on a system. Orchestration is the arranging of the automated tasks that result in coordinate process or workflow. There are several tools available to make configuration management easier, like Ansible, Chef, Puppet, and also Sort Stick. The goal of all these tools is to reduce the complexity and time involved in configuring and maintaining a large-scale network infrastructure with hundred, even thousands of devices. Okay, this same tool can be benefit a smaller network as well. All right, not just for the large network, also can benefit for the small network. Comparing Ansible, Chef, Puppet, and also Salt Stack. Ansible, Chef, Puppet, and Salt Stack all come with API documentation for configuring RESTful API requests. All of them support JSON, YAML, as well as other data format. The following table shows a summary of comparison of major characteristics of this of this configuration management tool like Puppet, Chef, SaltStack, and also Ansible. All right. What programming language for Ansible? First, using Python and YAML. Chef using Ruby, Puppet using Ruby, SaltStack using Python. Okay. And for agent-based or agentless, okay, for Ansible, they use agentless. For Chef, using agent-based. Puppet and also SaltStack, using both agentless and also agent-based. How are devices managed? So for Ansible, any device can be controller. Okay, Chef using Chef Master, Puppet, they have a Puppet Master, and also SaltStack, they got a Salt Master. What is it created by the tools? Using playbooks. For the Ansible Chef, we have a cookbook, and Puppet manifest, and also SaltStack using pillar. Okay. This is characteristic. That available in those configuration management tools. All right. Okay, now 14.6 IBM and Cisco DNA Center. Okay, here we have a video based on intent-based networking. You are learn of the many tools and software that can help you automate your network. Or intent-based networking, IBN, or Cisco Digital Network Architecture, DNA. Center can help you bring it all together to create an automated network. Okay, play the video by Cisco Jones Opotolos and also Anand Oswald explaining how artificial intelligence, which is AI, and intent-based networking, IBN, can improve network. All right. So we have a look now.
So now that I are going to describe how intent-based networking works and how AI comes into play. So 4 key areas. In the first, at the bottom, we have the infrastructure, which is the switches, the wireless APs, the routers, and so forth. On top is the intent. This is what the user wants to do. We take this intent, and then what we do is we translate it. Basically translate the intent, what we want to do, into the network and security policies which we want to apply in infrastructure. These network and security policies then are activated on the infrastructure.
And all these are done through open APIs, programmable models.
Exactly, something that Cisco is very focused on open-based, on standards and open APIs, and this is all done through open APIs. And then not only do you want to instantiate an intent on the infrastructure, you want to see, is it actually working the way it should? Is the network delivering the service as desired? And that's what's called assurance. The goal of assurance is to assure that the network is doing what's intended. Now, what's interesting here is that AI comes into play in all these different boxes. Once the intent has been activated on the network, we want to check, is the network operating as intended? And that's the goal of assurance. So what assurance does is it gathers a huge amounts of data and performs various analysis of data, behavioral analytics, and so forth to determine, is the network behaving as it should, or is there a problem? If there's a problem, where is the problem? What is the root cause of the problem, and how can we fix it? It then provides this feedback to the user, and the user then could say, hey, yes, I see that problem. I want to fix it as recommended. I'm going to instantiate that. It then gets instantiated in the infrastructure. And then we once again check to see if it works as intended. If it does, awesome. If not, we make additional changes. So we have this very powerful feedback loop here. And AI is in all the different parts. And by having AI, having this feedback loop and having AI, this accelerates what we're doing, improves agility, and overall, for the end customer, it improves the performance, reliability, and the security for it.
And this is also the layer where, in addition to doing baselining of all the data that we have, then we can now do anomaly detection, we can do now site comparisons, and then we can next go into predictability of what may happen sometime later in the future.
Yes, which is incredibly useful for our customers, because before they didn't have any of those capabilities. So this is really, really very valuable, very, very exciting time. Renan, myself, and many thousands of people spent about 5 years building this. So the reason it's so simple is because we spent about 5 years building it, and we're continuing to invest to build more and more capabilities into the intent-based network.
All right. Okay. So continue on this. Okay, that's regarding intent-based networking. How you can see the intelligent embed on that tools. Yeah. All right. Okay, IBN is the emerging industry model for the next generation of networking. Yeah, IBN builds on software-defined networking or SDN, transforming a hardware-centric and manual approach to designing and operating networks to one that is software-centric and fully automated. Yeah, business objectives for the network are expressed as intent. IBN captures business intent and use analytic, machine learning, and automation to align the network continuously and dynamically as business need change. IBN captures what? And translate business intent into network policy that can be automated and applied consistently across the network. Yeah. Cisco views IBN as having 3 essential functions. First, translation, activation, and also assurance. This function interact with the underlying physical and virtual infrastructure as shown in the figure. Okay, we have seen this on the video where they put an I in between this, right? Okay, this one they implement using AI. Okay, all right. So basically, they will interact with the physical infra. There's an infra here, like physical, all the switches, everything is here. Okay, translation. Yeah. Okay, the translation function enable the network administrator to express the expected networking behavior that will best support the best intents. This one, yeah, and translation first. Okay, right. Sorry. Yeah. Okay, right. So activations will be here. Okay, the capture intent, yeah, then needs to be interpreted, yeah, into policy that can be applied across the network. The activation function installs these policies into the physical and virtual network infrastructure using network-wide automation. Yeah. Insurance. Okay, which is for this. Yeah. So in order to continuously check that the express intent is honored by the network at any point in time, the assurance function maintain a continuous validation and verification loop. All right. So network infrastructure as a fabric. From the perspective of IBN or intent-based network, yeah, the physical and virtual network infrastructure is a fabric, an overlay that represent the logical, yeah, topology used to virtually connect to devices. So the overlay limits the number of devices that network administrator must program and provide services and alternative forwarding method not controlled by the underlying physical devices. The overlay actually is where encapsulation protocol like IPsec and also CAP-web occur. Yeah, using an IBN solution, the network administrator can use policies to specify, yeah, exactly what happened in the overlay control plan. Notice that how the switches are physically connected is not a concern of the overlay. Yeah, right. The underlay network is the physical topology. Yeah, that includes all all hardwares, yeah, required to meet business objective. The underlay reveals, yeah, additional devices and specify how these devices are connected. Endpoints such as the server in the figure access the network through the layer 2 devices. The underlay control plane is responsible for simple forwarding tasks. Yeah. Cisco Digital Network Architecture or DNA or DNA or Cisco DNA or Digital Network Architecture stand for DNA. Cisco implement IBN fabric using Cisco DNA. The business intent is securely, yeah, deployed into the network infrastructure, which is the fabric. Cisco DNA then continuously gather data from a multitude of sources like devices and also application to provide a rich context of information. This information can then be analyzed to make sure the network is performing securely at its optimal level and in accordance, yeah, with business intent and network policy. So Cisco DNA solution for SDSS, yeah. So what's the SDSS? First intent-based, yeah, enterprise networking solution built using Cisco DNA. It uses a single network fabric across LAN and wireless LAN to create a consistent, highly secure user experience. It segments user device and also application traffic and automates user access policies to establish the right policy for any user or device with any application across the networks. So this is how they manage it. So benefit for this SD access is enable network access in minutes for any user or device to any application without compromising security. Meanwhile, for SD-WAN, actually, it uses secure cloud deliver architecture to centrally manage one connection. It simplifies and accelerates delivery of secured, flexible, and also reach one services to connect data centers, branches, campuses, and also collocation of facilities. So this will give benefit, deliver better user experience for application residing on premise or in the cloud. Achieve greater agility and also cost saving through easier deployment and transport independent. Yeah. And Cisco DNA assurance. Okay, for Cisco DNA assurance, yeah, used to troubleshoot and increase IT productivity. It applies advanced analytic and machine learning to improve performance, yeah, and issue resolution and predict to ensure network performance. It provides real-time notification for network conditions that require attention. Okay, benefit for this actually allow you to identify root causes and provide suggested remediation for faster troubleshooting. And also the Cisco DNA Center provide an easy to use single dashboard with insight and drill down capabilities. And machine learning continually improve network intelligence to predict problem before they occur. All right, okay. So for Cisco DNS security, yeah, used to provide visibility by using the network as a sensor for real-time analysis and intelligence. It provides increased granular control to enforce policy and contain threats across the network. Benefit for this actually reduce risk and protect your organization against threats even in encrypted traffics. And it also gain 360-degree visibility through real-time analytic for deep intelligence across the network. Yeah, and it also lower complexity with end-to-end security. All right. So Cisco DNA Center. Cisco DNA Center is the foundational controller and analytic platform at the heart of Cisco DNA. It supports the expression of intent for multiple use cases, including basic automation capabilities, fabric provisioning, and policy-based segmentation in the enterprise network. Cisco DNS Center is a network management and command center for provisioning and configuring network devices. It is a hardware and software platform providing a single pane of glass or single interface that focuses on assurance, analytics, and automation. The DNA Center interface launch page give you an overall help summary and also network snapshot. From here, the network administrator can quickly drill down into area of interest. At the top, menus provide you access to DNA Center 5 main areas. As shown in the figure, these are design, policy, provision, assurance, and also platform. Okay, for design, yeah, model your entire network from site and building to devices and links, both physical and virtual across campus, branch one, and also cloud. Policy, use policy to automate and simplify network management, reducing costs, risk while speeding rollout of new and enhanced services. Provision, provide new services to user with ease, speed, and also security across your enterprise network, regardless of network size and also complexity. Assurance, use proactive monitoring and insight from the network devices and also application to predict problem faster and ensure that policy and configuration changes achieve the business intent and user experience you want. And for the platform, use API to integrate with your preferred IT system to create end-to-end solution and add support for multi-vendor devices. All right. So now have a look of video for DNS Center overview and platform API. This video is an overview of Cisco DNS Center GUI. It includes design, policy, provision, and assurance tools used to control multiple sites and multiple devices.
Hello everyone, this is Cisco DNA, Digital Network Architecture, and this is True Power. Like, no, it's not True Power, it's a command line interface. I get that, but here we are at the GUI of Cisco DNA Center, and this is also power. So let's talk about it. Even though it's a GUI, we love this system. Cisco DNA is all about intent-based networking and being able to use things such as policy, management, configuration, troubleshooting, all here in a GUI-based environment for multiple sites where each site can have hundreds of clients and dozens of network devices. So let's chat about it. Here we are at our DNA Center. It's a demo account, but we have 12 sites that we're managing, monitoring, configuring, and deploying devices at, all with the click of a mouse. These 12 sites are rolled out across the continental United States. On those 12 sites, we have 77 inter-networking devices. Inter-networking devices, not clients. We're talking routers, access points, firewalls, wireless LAN controllers. That's awesome. These things are going to be provisioned within our Cisco DNA Center so we can control them and configure them and update these devices live with the click of a button. We can roll out policies across these sites as well and have these devices being provisioned with these policies. We can roll out network profiles using addressing and SSIDs for wireless with security and configurations. We have images regarding our operating systems and being able to upgrade these OSs on these boxes live from anywhere inside of our 12 sites. We have our DNA licensed devices on top of that. So we're going to focus right here today on the network configuration and the operations area. And this corresponds to the tab bar at the top that we have up there for design, policy, provision, assurance, and platform. Design is where we start. We can create sites across the world where each site is going to have devices contained inside of it. We can roll out policies and configurations on top of those sites by dragging and dropping or clicking and just deploying. We can designate operating system images for groups of devices known as device families. I can create wireless profiles that we'll see, and we can literally drag and drop and roll these out across our network devices and entire sites across the world. Now, we really see our intent-based networking coming into play here with Cisco DNA regarding policy. And with policy, we get tons of power. That power that we're going to see is going to allow us to reduce our attack surface. We're going to be able to deploy access control list style protection across entire networks and sites and specific devices at the click of a button. We can completely accelerate incident response because we're going to get a live visibility of our users. The devices our users are using the applications our devices are using with those users, and even the processes running in the background. This is amazing to help us analyze and stop breaches on the fly. With provisioning, we can roll out and discover devices using protocols of CDP, LDP, and general IP. We can manage the unclaimed devices that have not been provisioned by the Cisco DNA Center service, but are being seen on our network. With assurance, we can do monitoring and troubleshooting on the fly. We'll hop into this shortly. And finally, with platform, Cisco DNA Center loves APIs. We have an API catalog that walks you through many different APIs that can be used to assist you in integrating your device and controlling and configuring the Cisco DNA Center system. For example, the categories, know your network. We have APIs regarding REST APIs for using GETs, where we can pull down information from the Cisco DNA Center regarding site health. We can post from our client device and specifically assign a brand new physical internet networking device we have in our hand. We can assign it to a site in Cisco DNA Center by using an API with post. If you don't know how to do it, you can just literally click it, and the DNA Center API catalog will walk you through how to do it. There's a code preview, a try it button. This is power.
All right. So now we're going to another video. Yeah. Just now previously we just for the DNS Center overview and platform API. Now we're going to show a video for DNS Center design and provision. Yeah. So this video is an overview of the Cisco DNS Center design and provision area where you can add new devices and update existing device. Okay, have a look at this.
So we're going to explore the design and provision area, and this is an awesome feature inside of Cisco DNA Center. In the design area, we're going to start off by taking a look at all the sites deployed across the continental United States. And then from there, we're going to jump into our settings and even be able to provision and add on new devices or upgrade current devices that we already have. So let's go into the network settings and talk about some of these sites that have been deployed. Now, in order for Cisco DNA Center to work, it's going to have to communicate with our critical services and servers. So we see we have our Cisco ICE server, Identity Services Engine. That's being used for our authentication in order to have our devices being command and controlled from our Cisco DNA Center. We've got DHCP specified, DNS is specified, syslog, SNMP, NTP, and of course the time zone and message of the day. That's cool. On device creds, how are we actually coordinating and working with the internet networking devices, of which we had 77 of them deployed across our 12 sites? Well, our Cisco DNA Center can utilize Cisco command line. So we've got our creds for username password, probably Cisco, and the enable password referenced as well. Besides CLI, our DNA Center can use SNMP. We have version 2C deployed at this time. We've got our community streams. It also supports SNMP version 3. It supports HTTPS, but we're not using it at this time. So let's just continue onwards. Address pools. Again, this is the power of intent-based networking and rolling out automated deployments. We can list out all the possible addressing pools across our 12 sites, and then we can reference these at any time on our network devices and inside of our site configuration. This is awesome. We have our SP profiles, which is our service provider. We use this for that quality of service. We list out the different service providers that we'll be using across the 12 sites, and again, we can reference these on those edge devices that are connecting outbound. Wireless is my personal favorite. Deploying our wireless profiles right here inside of our network settings, and again, referencing them at a later time. A quick example of what it looks like, I can click on my Corp SSID, click on Edit, and check it out. We've got our SSID name that we can edit, and it's used for voice and data or data only, iOS-specific fast lane, broadcasting the SSID, going dual band, as well as even security with enterprise or pre-shared key. I love this. This is so cool. Now, in image repository, we can actually focus here on those operating system updates and upgrades. We can list out those device families. We can even go in here and click on update devices and say, you know what, forget design, move onwards, provision. In provision, we have that update device button we clicked on where I can literally go inside of here check mark a network device, which we see listed as a specific site with a serial number, its uptime, what it is, the IP address. I can go to actions and I can update the operating system image right here with the click of a mouse. I love it.
Okay, all right. So that's regarding the DNS center design and provision. So that's very interesting. Yeah. So go to the next video. So this video regarding DNS center policy and assurance. This video will explain the Cisco DNS center policies and assurance areas. Yeah, the policy area enable you to create policy that reflect your organization business intent and deploy them across network and also devices. Assurance provides you with an interface to quickly view and troubleshoot devices connected to the network. Right, have a look now.
So let's talk about Cisco DNA Center policy and assurance. With policy, we can create policies that are going to reflect our organization's business intent. Now, this allows us to actually have the DNA Center take in information we provided. And we're going to have this policy that's going to be translated into network-specific and even device-specific configurations. Now, besides policy, we're going to hop into assurance as well. And with assurance, we can increase the visibility of our network status down to even user devices. Also, this can help us save time by looking through false positives and even having a reduced workload by having Cisco DNA Center proactively find solutions for us regarding our network issues. So let's jump in. In policy, we can take a look at the different policies that have been deployed at this time and check it out. We got bring your own device, development servers, even HR with a bring your, that sounds scary, HR bring your own device. But you can see the different policies that have been created, and these are the policies that are then going to be deployed and provisioned across multiple devices. We can see the sources based off of who's going to be the source of the network traffic, destination, the BYOD, and then of course the contract and what's being allowed, which is permit. For us though, we can compare some items such as IP-based access control, which takes you back to your IPv4 access control list days. When I click things like add policy, check it out. Source, similar to IPv4. Contract, what you're allowed, no, cool. Destination, and where you're going. And then direction. We're talking bi-directional or one way. Very similar to the access controls we've done in our CLI work. Now, with things like assurance, we can focus here on the health of your network, but also on the troubleshooting. For example, if I scroll down, top 10 issues, priority 1 can make or break you. This is causing downtime for many users or even many sites. So I'm going to go ahead and click on this first issue that's listed here. I get my different instances of this issue that it's occurring. I'll go ahead and click on the first one regarding lost connectivity to the identity services engine. And if I scroll down here, hey, suggested actions. Verify whether the identity service engine server is up. Cool, I did that. Next one, verify the route to the identity service engine. Hey, there's a run button. Cisco DNA, can you help me? And it says, well, yes, I can. So I'll go ahead and click on run and check it out. It's going to do the show IP route command for that specific entry, and it's going to see if it's successful in finding that route. We have a success. It exists. We check our Cisco Express forwarding for that specific route. Success. It exists. Continue onwards. Let's verify our interior gateway protocol adjacencies. Let's go for it. Click run. It checks ISIS. Exists. OSPF. Good to go. EIGRP. We're friendly. And if you still can't fix it after all this, you know what? Just contact Cisco Tech. They'll take care of you. This is the power of having this view, this intent-based networking deployment.
All right, that's pretty cool about the the system. Yeah. Here we go for the next slide. Yeah, another video as well. So DNS center troubleshooting using connectivity. So this video will explain how to use DNA center to troubleshoot devices. All right, so we have a look now.
Hello everyone, it is go time. We're going to use Cisco DNA Center to troubleshoot some user connectivity. Let's just jump in and get started. Grace has contacted us and asked us for help. So I'm going to go ahead up here to my little search button and I'll click on that search. And we're going to type in Grace. And check this out. This is using the Cisco ISE, which is Cisco ICE or Identity Service Engine, and it's hooked together to see Grace's devices and even her user account. We're going to go straight to her user account and we're going to click on User 360. Now, when this opens up, that's the power. We've got 24 hours of visibility by default right here, tracking Grace's devices. We see Grace Miss iPad, her iPhone, and a PC. We're going to go ahead and click on the iPhone. When we click on the iPhone, this is going to load up and show us some awesome information. The Cisco DNA Center recognizes that Grace's phone is an iPhone 7. Her MAC address is shown right here. Here's her IPv4 address, IPv6 address, VLAN ID of 120, and Grace is currently connected. The last seen, time and date, as well as even the current network device that Grace is connected to. The access point is an AP4800. And there is the wireless SSID that Grace is joined with. Now check it out. We can actually see some things inside of here, such as health and the events. I'm going to scroll down and we're going to use this in just a little bit in order to try to take a look at some of the complaints that Grace is having on connectivity. Maybe it's over here in this red area. Let's go see, take a look down below. So there's a couple of issues listed regarding Grace's device. We can see right here, client disconnected. All right, dual band capable client. Oh, Grace's device prefers 2.4 or 5 gigahertz. Maybe it's a range issue. You know, if it's a dual band device that supports both, 5 gigahertz may be a faster speed for her to connect on. Why is her device preferring 2.4? So again, possibly a range issue that we'll take a look at. So I'm going to scroll down a little bit here. And here is Event Viewer. And with Event Viewer, we might be able to get a better view of what's going on regarding Grace's device. On the right side here, we can get detailed information on any item that we click on. Here's a broadcast read key that's shown up in red. So I'm going to expand the broadcast read key, and let's get a closer look at this. So there's a key exchange issue. I can click on that, and with the key exchange issue, this is a 4-way keyway timeout. So it looks like there's a timeout occurring regarding some type of authentication that's going on between Grace's device and our wireless network. So if I scroll down a little bit more, we've got things like path trace, application experience, and then of course, detailed information for connectivity. But take a look. With integration for iOS, there's even iOS analytics that can come into play here specific for iOS devices. Powerful, huh? Well, let's scroll up to the top, and we're going to take a look at something that's really cool called Intelligent Capture. I click on Intelligent Capture, and this is going to load. Once this loads up, we get a live view with a heat map of Grace's device and her moving through the office building and being able to see all those access points that are deployed. That's powerful in itself. And I can actually scroll and look at a specific timestamp regarding where Grace was at that location during times of, let's say, events that have occurred. So I can even search based off of only anomalies that have occurred regarding Grace's device on the network. Again, this is not for all devices. We're focusing on Grace Smith's iPhone right now. This is true power, and it is awesome. We can take a look and see the signal to noise ratio. We can see the floor level, decibels. And if I scroll down a little further, what we want to get at is even take a look at the different type of packets and applications that Grace's device is using back and forth across the network. So when we talk about full troubleshooting down to the user across a live corporate environment with over 70 some network devices and hundreds if not thousands of users, we have Cisco DNA Center that can take care of us. Let me show you the power behind how it takes care of us with users and the network devices. So I'm going to go ahead and click on Anomaly. With Anomaly selected, we only see those issues here on the left side. Now I'm going to go ahead and click on Broad 3 key, which is our timestamp of 9:56 and 30 seconds in the AM. Now the neat thing is it's going to pull up information regarding that event, including that heat map at that time. Now if I scroll down here, we'll have the heat map where Grace's iPhone was, but even below that, we've got an auto packet analyzer, and this is going to be showing us messages where we have triangles that are up and triangles that are down. And triangles that are in the up form are Grace's device talking with the wireless network. When we have triangles coming in that down, that's going to be coming back from the wireless network itself. So we can even go into the analytics of analyzing the messages between the wireless access points in the wireless LAN controller, and Grace's iPhone itself. This is the true power that sits behind all of our troubleshooting and gives you that visibility using Cisco DNA Center. Now you may say, I see these GUI tools for troubleshooting. I've got my power and command line. I know how to troubleshoot using my show commands as well as my tools for my troubleshooting toolkit. But when it comes down to it and talking about large enterprise deployments and what Cisco DNA Center was designed to handle, imagine the cost that would exist of troubleshooting 800 users on a network over the point of a year. What it comes down to is you take a look at something as basic as a trace route. With trace route in Cisco DNA Center, you get instantaneous feedback, results, and analytics. With traditional CLI, a trace route, and actually understanding, going through it, and making sense of it, would take you about 6 minutes on average. You're talking 6 minutes of savings immediately. Now imagine doing a trace route 25 times in a week. That would save you about 2.5 hours per week, times, many weeks in the year, would save you about 15 days just regarding using trace route. If you talk about onboarding users and onboarding devices with the same type of scenario, you've got a 15-minute average savings of using Cisco DNA Center versus traditional command line. And again, it adds up over a year. We're looking at 30 days of troubleshooting saving. To the end, when we go straight to the last one here of site visit, not having to go on site because we have Cisco DNA Center that can run in the cloud or on a network server, and then the traditional savings of 3 hours of time. Occurrence, maybe once every 2 weeks. That's as marked as 0.5. And that would save you 9 days of on-site visits each year. This adds up to about 90 days of troubleshooting saving. There's only 365 days in a year. And imagine getting 90 days of just troubleshooting because of Cisco DNA Center. The power is here and this tool is amazing. Get started and do some research and study on the Cisco DNA Center.
All right. Okay, that's very interesting. So that's regarding Cisco DNA Center, to troubleshoot devices, whether huge devices, many or large scale, and also for the small scale. All right. Okay, that's all. Thank you for watching.